Hi, Josie, you're muted.
So sorry. Thank you. Hello, everyone. Thank you all for joining us today. My name is Jasmine. I'm a course advisor for the Engineering Institute of Technology, which is super exciting. The webinar will be, well, technical part of the webinar will be starting shortly. I'll just need to take you through a bit of information prior to that. So just in regards to notifications and sound, just for your benefit, it's better to turn off any notifications and sounds, just so then you can really focus in on the session. Now, this will be important towards the end, so it'll be for your benefit overall. Now, please post any questions in the Q&A function. It's just easier for the wonderful Derry to have a look through it during that point in time as well. So it's just good across the board. With common questions, the webinar slides/video will be sent out in an email within the next 2 business days. Now, sometimes this can land in your junk email or promotional inbox as well. That's possible for Gmail. So just keep an eye out on this as well. With the technical webinars, you are required to submit a little bit of a survey, but you will be provided the certificate of attendance link and QR code towards the end. So there's no stress in regards to that. About the Engineering College of Technology and the Engineering Institute of Technology, sorry. We are a specialized college, which means we just focus on engineering and technology, which means we can be industry focused and expert led, which is ideal. Sorry, just bear with me. We have a really good methodology behind providing as much support as possible whilst maintaining practicality throughout it all through our remote labs. We do have a video on this on our YouTube channel as well, so feel free to check that out. It's just we try to provide accessible, high quality education across the board with innovation and engaging practical online learning. So just a disclaimer, the courses and qualifications mentioned in this presentation are offered by separate legal entities operating in different jurisdictions, one in Australia and one in the United Kingdom. Each entity is subject to its own local regulatory requirements and accreditation standards. Prospective students should refer to relevant institutions' official websites for accurate, up-to-date information specific to their local location, including course availability, fees, regulatory status, and enrollment conditions for Engineering Institute of Technology. There's a link, and then for the Engineering College of Technology, there is another link, which is fantastic. So I'll just introduce. So today we're doing the introduction to industrial piping and pipeline systems by Dr. I'll bring on to present now.
Yeah, good everyone. So can you hear me? Oh, good.
Yes.
So good everyone. Yeah, we'll be going to 45 minutes class of introduction of industrial piping and pipeline systems. So my name is Dali Jeremiah, and I'll be your anchor for now for the next 45 minutes. So hopefully you'll be able to gain some basic knowledge, and I'll be able to convince you that you are going to have interest in becoming a piping engineer or pipeline engineer, so to say. So this is just me. So we'll just divide the webinar into 3 sections. We just look at the overview, Then from there, we move to piping system, industrial piping system, more focus on that. And then we now go to pipeline system. Now, what is the expectation of this short webinar? Is to grab some basic concept, terminology, and related to piping and pipelines. A lot of people are actually confused because both of them consist of piping, pipeline. What's the difference? Are they not the same? So if someone is a piping engineer, is it the same thing as pipeline engineer? So hopefully before the end of the webinar, you'll be able to differentiate the two of them and know, okay, this is the area, this is what is piping, this is what is pipeline. Then we'll be able to differentiate them. Then we'll now be able to identify major components and have some basic understanding the kind of design that we do in both component, piping and pipeline. So let's look at when you are talking of piping and pipeline, they both form the
Sorry
circulatory
to
network.
interrupt.
Yeah.
I just want to make sure that you've taken control of the slides.
Yeah. I think it's from I can take on yeah.
Yeah.
Is it okay now?
Have you
Yeah, I can navigate.
It should be up in your top left corner or bottom left corner, depending
Okay,
on where
yeah.
your taskbar
Okay,
is.
I've seen it. I've seen it.
Yep, yep. Wonderful. There we go.
Uh,
Thank you so much.
Okay. Okay. Yeah. Sorry. So good. Okay, yeah, I can see now. So as I was saying, that we were looking at the basic concept of the terminology related to piping and pipeline system. Then we now look at the differences because sometimes even in the class you ask some engineers what's the difference between piping and pipeline engineer. Both of them comprises of when you look at the word pipe. So what's the difference? And then we now try to look at some major components of each of them. So we'll be looking at when you look at the overview, both piping and pipeline system form a circulatory network of process and energy industry. Okay. Okay, good. Sorry, I'm having an issue. So
Did you need assistance
what?
with anything?
No, it's okay now. It's okay now because it's a bit blurred, but it's okay.
Okay, awesome. Thank you.
They both transport fluid, but one transport fluid within the facility, while the other transport fluid from one facility to another facility. So when you're talking of liquid, gases, slurries, vapor between equipment, storage facility, and distribution point. And these systems, they are more prevalent in the oil and gas industry, petroleum, petrochemical, power generation, water treatment, pharmaceutical, and food industry. Now, the first question is that what is a pipe? When you say pipe, is when a fluid is required to be transferred from one location to other, you need a pipe. So as simple as that. Where do I need a pipe? You need a pipe when a fluid is transferred from one location to another. It can even be from your kitchen to your toilet, from the water tap at the backyard that you used to wash your car to you need a pipe. However, when you're talking of piping system, is a network of those pipes within a facility or facilities that connect process equipment such as pumps, vessels, heat exchanger, and compressors. And you will understand it. I will use something that you will understand. So inside your house, you have a piping network that goes to your kitchen, goes to your toilet, that carries water. Though those pipes may actually not be steel, it may just be ordinary rubber or plastic, but it's still a pipe. So within the house, that is piping system. While pipeline system is a long distance transport system, either buried or subsea, that move the crude oil, natural gas, or refined product between the production sites, refineries, and consumers. So let me still use the same analogy concerning your house. You have a house, the piping inside the house, they are actually for piping, which is within the house. Now, let's say you have another house that is 2 kilometers away, and your main water pump is actually in the first house. Where you transport water from the first house to the second house, that is where we call it pipeline. So from one facility to another facility. Now, let's now take it one by one. Piping. What is piping? As I've said, within the facility. So it's like a nervous system for the flow of fluid in a huge network of any industry around the globe. So it is an assembly of pipes, valves, instrument, and specialty components. And within the industry, piping is a system of pipe used to convey fluid, liquid or gas from one location to another, just within the. And the engineering discipline of piping design study for efficient transport is called piping engineering. So that's why some people, they will ask them, what's your profession? I'm a piping engineer. So to know about piping and to design piping, write specification, do everything about piping, that is what we call piping engineering. So now, what is the purpose and function of piping system? As I said, it transports process utility fluid safely and efficiently. So it's an interconnecting process equipment like pumps, vessels, heat exchanger, compressors, and reactors. What does it do? It control, it measure, it regulate flow, it pressure and temperature of the fluid, and then provide containment and safety against leakage, corrosion, or explosion. So these are what the piping is all about. Now, how do we now categorize the pipe sizes when it comes to piping? They are designated by two numbers, the diameter and the thickness. The diameter and the thickness. And pipe sizes are documented by number of standards. For example, we have API 500, we have ASME B36.10 in the US and BS in UK, and BS 1600 and 1380. And then piping can be divided into two main categories. Don't forget I said when it comes to the pipe sizes, we have two designations, which is diameter and thickness. That means the thickness of the wall of the steel, while the diameter is the length across the pipe. Now, piping can be further divided into two main categories. We have the small bore lines, which their nominal diameter is 2 inch and under. And then we have the large bore lines, which is greater than 2 inch nominal thickness as large bore. So what are the main components of piping system, which I will still talk about in the next slide? anytime you talk about piping, does that mean that it's just ordinary pipe? Yes, it's part of the pipe. The ordinary pipe is part of it, but it comes with some components. So the first one is just the pipe. But we have other things because pipe cannot just stand on its own. So we have flanges, we have stop end, we have gasket, we have elbows, we have reducer, we have T-joint, we have expansion joint, we have pipe support, we have instrumentation, and we have pipe rank. So just a little bit of what I just mentioned now. When you look at the pipe, what's the role of the pipe in the piping? Is the main passage for the fluid. The sizes defined by nominal diameter as schedule, which is the thickness, as I've mentioned before. Then we look at the fittings. Because the pipe has to be fitted with each other. You can't just take a pipe and say, okay, small pipe, I just place it by each other. When you place it by each other, diagonal, vertical, and they are not connected, it means that the fluid will not convey to the where you want it to go. So how do we connect it? We use fittings like elbows, teeth, reducers, couplings used for direction and size changes. At the same time, when our piping, the fluid is flowing, we need to control. So what do we use? We use valves. That's control devices for starting, for stopping, and for throttling flow. At the same time, we can actually join them together. So that's the use of flanges and gaskets, which either we to disassemble it or for maintenance of the pipe joint. And some of these pipe, especially when you go to a typical refineries, you go to LNG, you go to pharmaceutical factory, these pipes, they need support. So because they need support, bear pipe weight, maintain alignment, and allow control movement. And then another component, which is instrumentation, because there are some pressure gauges, temperature sensors, and flow meters for monitoring and for control. Now, what are the materials? When you're talking of piping materials, what kind of material are they made of? The material selection depends on the operating pressure, operating temperature, and the fluid type. So, for example, if it is carbon steel, which is commonly used in the oil and gas and water services, where we have stainless steel, which is for corrosive or high temperature fluid, and then we have alloy steel, which for high pressure and high temperature service, and we have some non-metallic materials for water, for chemical, and for low pressure service. Now, how do we classify? Don't forget that we have looked at in terms of sizes, we said we put it in two sizes, diameter and thickness. In terms of category, small bore, large bore. Now, we can classify it based on other things apart from the size. We can classify it based on the service type. So we have process piping system, utility piping system, safety relief piping system, instrumental fire water piping system. And at the same time, we can still categorize it based on pressure rating. We have the low pressure rating piping system, medium, high pressure rating. And we can still categorize piping system by function, like suction, discharge pipe, suction pipe, drainage pipe, venting pipe, cooling pipe. If you look at your air conditioner at home, they will tell you that you will see a pipe that they put at the back of the air conditioner that take out water. So it's like that one, that discharge pipe, venting pipe, cooling pipe, and chemical injection lines. Now, why is piping engineering very important? Maybe you're a student here, or you are thinking of, you're already a mechanical engineering student, materials engineering student, civil engineering student, and this is the area you are having interest. The reason why it's very important and the reason why the industry needs you is because of safety. I believe if a plumber come to your house and do some piping network under your kitchen, and at the end of the day, after he left, you open your tap in the kitchen and everything starts coming out. The water start coming out. What will happen? You have to call the plumber back. So safety. So those are the basic design criteria. And we have cost. Especially when you're talking of the material selection. And then we have some codes that we use in the industry. As soon as you step into the industry and begin to do piping engineering, design, it's no longer about theory. You have been taught theory in the university, it's now about codes and standards that regulate and guide whatever we do. So we have some code that is majorly for the piping, like ASME B31.3, which is for process piping, ASME B31.1, which is for power piping, and we have ASME B13 2016 series. Those are for fittings, flanges, and valves. And then we have API 570, which is for inspection, repair, and alterations. So now, when we are doing pipeline activities, because we're just trying to touch the basics, there's some drawing activities that is very, very important in piping. So we have some engineering drawings, which are technical documents that represent the layout, the design, construction detail for piping system in industrial facility. So they are essential for design communication, fabrication, construction, and maintenance, which will now ensure all stakeholders. Who are the stakeholders? The engineers, the fabricators, the contractors, the inspector, to understand the system configuration and specification. So when you see a typical piping general layout, you see a lot of connection. You will not be wondering what is this one. Those drawings are actually very important when you are talking of piping. So I will just list one or two of them, few of them. We have the process flow diagram. If you look at the diagram there, you have seen how it flow. What does it do? It provides an overall view of the major process unit flow of material within a plant that is going to move from point A, you see the arrow, to its exchanger. From there is going to vessel. So it will show us the flow from one equipment to another equipment. So it's just like now when somebody want to eat a food, how does he eat food? We have to take a food, enter his mouth. So the flow is from the hand to the mouth, and then from the mouth to the stomach. That's the flow. So what that one has done for us now is typically a process flow diagram for eating your food. So if I want to make a draw now, I will draw the hand with a flow, and from there to the mouth, from the mouth. So that's why when you see someone that they feed the person indirectly by passing some drip, we know the person is sick because it's going against the flow. The second diagram that is very common in the piping is piping and instrumentation diagram, which is called P&ID. You can call it piping and instrumentation drawing diagram, so on, or instrument diagram, but everything means the same thing. Is more detailed than the PFD. The PFD is just showing you the arrow from one equipment is moving to the other one. But this one now, it will show you the in detail relationship between the piping, the process equipment, and the instrumentation. While the other one is just overview of the process unit and the flow of the materials within the plant. So then the other one is piping general arrangement, which is to provide the physical layout and the spatial arrangement of the piping system within a plant or module. What does this one do? You will be able to look, okay, this one is going to be the east, west, the pump will be down, another pump will be at this vessel, and then you will be showing the arrow, but it's showing you the locations. And then we have piping isometric drawing. This represents the 3D view of a single line or a section of the piping system. And then, of course, we have the orthogonal drawing, which is not here. The orthogonal drawing, we can draw the isometric drawing from orthogonal drawing. Orthogonal drawing is just a section, 3 sections, and then we bring it together. Then we have pipe support drawing. As I was saying, that we have pipe support. our piping need to be supported. So this is the design and placement of support to sustain the piping loads. Then we have plot plan and or equipment layout. This is like you have a whole equipment layout, the plant area. You look at the top view layout of all the major equipment. So you'll be able to see everything in one. Just like somebody what you want to check the street and you put a drone to just give you the overview of the top view of the street. That is like a plot plan. Now, then we have line routing. So this is, we always do this one, line sketches during the conceptual layout for pipe routing between equipment. Where is it going to follow? Where is it not going to follow? Is it going to pass through A, B? So just like a normal initial sketch. And then we have the material takeoff. This is the list of all the material required for fabrication and installation. The pipe support, the flanges, will tell you everything. Now, what's the relationship, interrelation between the two of them, between all this drawing? Now, when you look at PFD, process flow diagram, where do we use it? Where do we need it? Where do we do the job? Where do we do the drawing? During the conceptual drawing or feed, that's feed is front-end engineering design. And why do we need it? For process design overview. Before we do our design. And then we have P&ID. We use P&ID with the stage of the project is detailed design. So, when you are talking of engineering design has a stage. We have from the feasibility studies, we have options, and then we move it to concept, where you develop a concept. From there to feed, which is front-end engineering design. Another name for feed is basic engineering. And then from feed, they make an investment decision that they are going ahead for the project. And it goes to detailed engineering. From detailed engineering to fabrication or procurement, from their installation and to commissioning. And that's the stages of project. So then we have GA. We use it during the detailed design too. It's made for layout and installation. Then we have isometric drawing, like all those 3D that I was showing you. Isometric drawing, we use it for fabrication, which is for during the fabrication for those are for shop drawing, for construction and welding. Then MTO, material takeoff, is for procurement and material estimation. So now, in summary, all industrial piping systems are fundamental to process industries, linking the equipment, transferring energy and materials, maintaining safe plant operations. Its design needs to integrate mechanical integrity, fluid dynamics, materials engineering, safety compliant to ensure reliable, efficient performance throughout its life cycle. So at least I'll be able to convince you that you're going to be a very good piping engineer. So now let's move it to become a pipeline engineer. Don't forget the piping is within a facility, within your house, within LNG plant, within refineries, within petrochemical, within pharmaceutical center. Now the pipeline system is a bit different. So they all have pipe. But this one now is going to be a long, continuous network of pipes, associated facility designed to transport. So it means the other one, transport, was within the system, but this one now is transport over a long distance from point A to point B, from village A to village B, from one country to another country. So the pipeline serves as an artery of energy and process industry, providing safe, efficient, and economical method for transporting large volume of fluid from production site to process facility, to storage terminals or end user. So let's say from the oil production facility, we take a pipeline, we take our crude oil to LNG, or we take crude oil to refinery, gas to LNG. So that is the means of transportation. However, what are the purpose and the function of a pipeline system? There are four major area is for transportation, conveying the hydrocarbon or water or chemical or CO2 from one location to another. And then we use it for distribution, delivering processed product to refineries, power stations, or consumers. And we can still use it for collection. We call them gathering pipelines, gathering, gathering fluid from multiple wells or process sources. So sometimes we call it flow lines. Then we have injection lines for delivering gas, water, or chemical for reservoir pressure maintenance and processing support. Then we have, just like the way we have many components for piping, there's some component too that a pipeline does not stand on its own. So we have the pipeline, which is the pipe section. This is the main conduit, usually steel or carbon steel, welded and joined to form a continuous length. It can be seamless, it can be submerged arc welded. Then we have the valves and the fittings, which enable the isolation, control, or the direction of flow. And we have pumps and compressors. This provide the pressure required to move the fluid along the pipeline. So if it is pumps, you are talking of that we are supposed to move our oil. If it is compressor, you are talking of gas. Then we have pig launchers and receivers. It facilitates the extraction and retrieval of pipeline cleaning like pigs. When we want to clean the pipeline, we need pig launcher that will launch our pig, and we need the one that will receive it. And then we have the metering stations. This is to measure the flow rate, measure pressure, product quantity for the monitoring and custody transfer. We have block valve stations, which allow the sectional isolation control system, provide remote monitoring, control, and leak detection. Then we have cathodic protection system. This to provide corrosion for buried or subsea pipeline. And we have support, expansion loops, anchors. This to manage the mechanical loads, thermal expansions, and environmental forces. I said there are different kind of pipelines. So now, this type of pipelines now, which I've mentioned, gas utility, we have transmission, distribution, gathering lines, and we have utility line which carries water and so on. Now, the pipeline can be further categorized based on the location. If your pipeline is on the land, swamp, river, we call it onshore pipeline. If it's inside the water, like shallow water, deep water, sea, we call it offshore pipeline or subsea pipeline. So this subsea pipeline now is installed on or below the seabed for offshore oil and gas production. Now, for the subsea pipeline, we can further divide it into two categories. We have the flow lines, we have the trunk line. What is a flow line? A flow line is just like this one is longer, but just like a piping that's within a facility. So this flow line is a pipeline that within an oil and gas facility, oil and gas field, that carried the unprocessed fluid, unprocessed crude, unprocessed gas from the well to the platform. So we call it in-field pipeline within the field. So if flow, we call it flow line. So sometimes when you see an advert, we are looking for flow line engineer. Then we have export. Export pipeline is moving a processed fluid from FPSO to another place. They can move it from Singapore to Perth, from Singapore to Malaysia, from India to Abu Dhabi, and so on. So that is export pipeline, a Trans-Alaska pipeline. Now, why do we use pipeline? Pipeline as an alternative, which I will first start with there. When you want to transport fluid from point A to point B, that means you need huge quantities over a long distance from point A to point B, or small quantities over a short distance. What are the options do we have? We have two options. It's that we use batched or piped. It's either we batch it or pipe it. So now the batch is like tank. You see petroleum tankers going to your gas stations. So petroleum tanker go to your gas stations. That is, instead of them laying a pipeline from a refinery to different gas station, they use a barge and tanker. So what do? They pour it in, they move the tank, and they empty it out. So anytime you see a petroleum tanker at the gas station, just know that pipeline can do the job too. But because there will be too many commotions and network of pipeline to go to different filling stations, so that's why the pipeline will take it to like a storage, and then the tanker will move it from there, or like a tank farm. So the tank transport is very good because there's low capex. What is capex? Capital expenditure. The money that is used to build it. All what you need to do at that stage, the advantage of it, all what you need to do is to just buy a tanker. That's all. And begin to, but it has an OPEX problem, which is operating expenditure, because you need to be buying fuel, you need to be repairing the engine, you need to service the engine, you need to pay the driver. So the operating of the tanker is more higher than pipeline. And then it has flexible route, because you can decide to say this tank go to Baga, this tank go to Medaboka, this tank go to, so it can change its route. At the treasure, you can decide to make the tank to go on rail, smaller quantities of high value, and then safety through integrity of the tank can be managed. They change the state of the fluid. They can still use it by using 39%, 30% of the internal energy for the product to transport. That is because we are moving from one place to another. We can do a LNG, liquefied natural gas liquefaction, or we can do a regasification. But for pipeline, why is it important that we should choose pipeline? Number one, is safe and continuous. Don't forget that the tank can get an accident. The tank, the pipeline, the problem is that the moment you lay it, it can be there for the next 30 years. And I'm not sure anybody can use a petroleum tanker or gas tanker for 30 years. So lay the pipeline is safe and continuous transportation, and is economical for long distance and high volume transfer. For example, they can lay a pipeline from Perth or from Timor Sea to Singapore. Then it has a low environmental footprint compared to road or rail transport. Reliable operation under automated control. But if we say pipeline is good, there must still be some disadvantage. But disadvantage is what is an advantage for us as pipeline engineer. Corrosion and erosion can happen, but we need to find a way to guard against it. External interference like mechanical damage, third-party activities, leak detection and repair, environmental and regulatory constraint, geohazard, and aging infrastructure. So it is that no disadvantage too, but by the time you compare it, you see that it's better. Now, in order, just like when I was mentioning about the code for piping, for pipeline, we have some specific code and standard that we use in the industry. Several design code exist, both nationally and internationally. The codes are developed to ensure that the pipeline system have an acceptable safety level during installation and operation. But I will just tell you the popular ones. ASME bit at 1.8 is for pipeline that is carrying crude, that's liquid. Bit at 1.4 is for crude. Bit at 1.8 is for gas. And then we have the API 5L, that is for the specification of the line pipe. You want to get the recommended sizes. Then we have the ISO 13623 for the pipeline transportation system. We have the welding of pipeline, the API 1111, and then we have DMV F101. Now, this code, they are divided into two options, depending on what you are looking for. we have the allowable stress design code and we have the limit state design code. The allowable stress design code, it's based on the lack clarity on the failure mode. So when you look at your, for some of you that maybe you did a little bit of physics, your Young modulus, your stress against strain, and you are trying to plot it, it will get to a place that will get to a yield stress. So allowable, we say, okay, don't pass this stage. But the limit stage, we say, go to the ultimate design. So it's an unknown margin of safety and it deal with track record and ease of application. But so we have asymptotic beta 12.8, asymptotic beta 1.4, they are under stress-based design, which is a reliable-based design. And then the limit state design is a clearer basis of formulation, explicit level of safety, level of test data requirement. So example of that code is DMV F101 API 1111. So what are the considerations? Now, when you look at when we are talking about the piping, we are more concerned about the drawing. We do some analysis there too, which is stress analysis and so, but in pipeline engineering, you do more of analysis. We do drawing too, but more the drawing comes from our analysis. So we have multiple engineering discipline that we always look at. For example, one of the things that our concern is the fluid property, the density, the viscosity, the temperature, the phase behavior. We look at how is it going to flow from point A, because your pipeline can be 10 kilometers. Your pipeline can be, for example, the longest pipeline, subsea pipeline in the whole world is from Norway to UK that carry gas to UK, which is 1,200 kilometer pipeline. So can you now imagine if the oil or the gas enter from inlet pressure, by the time it gets to 1,000 kilometers, a lot could have happened. The pressure could have dropped, the temperature could have gone down, and that can cause a problem for us. So like wax, hydrate, slugging. It's just like you put your oil inside the you put your oil and you eat it, put it in the pot, and you leave it from morning. You go to work. By the time you come back, the oil will have become very cold. So that's exactly what happened. Because by the time it transfers over a period of time, and then we look at the mechanical design, which I'm going to explain by the time we get to the deliverables, the little time, pressure containment, the collapse, fatigue, environmental and geotechnical conditions is another thing we look at, because your pipeline is moving from a deep water, for example, 1,000-meter deep water, and it's going to shallow water, going to the beach. So you go for that, it's going to move from current that is very high to shallow water that the wave is very high, and then to the beach, and the beach, the wind is very high. So your pipeline is moving from different environmental conditions. And don't forget that the soil can change too. It can be very clay in the first end and loamy, sandy till it gets to, and they're rocky sometimes. Then we need to now think of the safety, the reliability, integrity management. Then how do we install the pipeline? For subsea, there are different ways we can install it. You can use S-lay, J-lay, relay, and tow. So these are pipeline project activities. We have the route. You first look at the route. You do all the necessary. After you have looked the route, I'm going to lay my pipeline from point A to point B. What is the route? Where am I passing? Okay, I will pass A, I will pass B. That is the route. That will make you to know, okay, I'm going to manufacture it and I'm going to procure it. But when I procure it, I'm going to design it to make sure that the design and our pipeline is okay. Then from there, we install and connect to system and ready for startup. So these are typical main project activities. However, for subsea pipeline, for offshore pipeline, there are a range of design activities that is very, very important. And these are the areas that make a subsea pipeline engineer to be an hot cake. all over the world. Because before you lay the pipeline, you need to get the routing, you need to select the material. After you select the material, you need to calculate the wall thickness. What's the wall thickness at every stage? And the wall thickness, I need to look at, okay, this wall thickness, I need to make sure that my wall can withstand the pressure to avoid burst. I need to make sure that my wall thickness can withstand the pressure from the external to avoid collapse. I need to make sure that when the pipeline is being bent and my wall thickness will be to, so you need to do some calculations. And of course, you don't forget that we say one of the challenges is corrosion. Corrosion. How do we guard against the corrosion? Then I'll go to put some anti-corrosion coating like fusion bonded epoxy, cathodic protection, which is just a way of protecting it with the coating to make sure that our pipeline remains safe and reliable and did not corrode for 25 years. Then if the pipeline is going to be, they discover that there's going to be a formation of wax, hydrate, we can decide to make a pipeline and insulate it. Now the pipeline is going to be put on the seabed because of the waves, the submerged weight, the wave, the current, the pipeline may not be stable. So we perform an analysis to make sure that our pipeline is heavy to the level that it can be safe. And then we have another thing that we don't like on pipeline laying on the seabed is that, you know, when your pipeline is laying on the seabed, but there are the topography of the seabed is undulating. There will be some areas along under the pipeline that it will not be touching the ground. So when it's not touching the ground, we call it a span analysis. So we don't want that one. So we do of course pilot. Then another thing we don't want is because due to the temperature and the pressure inside the pipeline, our pipeline can contract, can expand. So we perform what we call pipeline expansion analysis. And of course, rigid tie spool to cater for that, we can decide to stretch the pipe, to stretch the floor and put our pipeline and bury it. Another thing we don't want for the pipeline is that if they are restricted on both ends, it can cause what we call aquifer buckling. And if you put it on the seabed, it can begin to move and cause a lateral movement. Another problem is what if there's a pipeline there before, an existing pipeline? We need to cross it. How do we cross it? And how do we protect our pipeline? So this is just some basic analysis that is being done. Then one of the things again is operation and maintenance. The effective operation of pipeline focuses on pressure, temperature, flow monitoring, corrosion and leak detection system, picking operation of the cleaning, emergency response and shutdown. And as I'll be running up, the pipeline system are essential for the global energy and process industry, providing reliable, continuous transport of oil fluid. So that's why they are designed operation demand integration of mechanical, civil, materials, and control engineering discipline with a strong focus on safety, reliability, and environmental stewardship. So I'll be able to tell you if you want to be a piping engineer, maybe you must love how to do drawings very well. If you want to be a pipeline engineer, you must like calculations. Those are the two differences. But your background, maybe you're a mechanical engineer, civil engineering, materials engineering, metallurgical engineering, you are welcome. We want you and we are looking for you. So conclusion, industrial piping and pipeline are lifeline of modern industry designed to ensure safety, reliable and efficient transport. So the engineering integrates mechanics, materials, thermodynamics, safety management with strict regulatory framework. So thank you. So I'll be able to convince you that you are going to be a good and great piping engineer and pipeline engineer. So thank you.
Thank you, Dr. Dare. I really appreciate your time and thank you everyone else for joining us today. I'll take control back for now. Please ensure to use the Q&A section if you do have some questions. I think that's a wonderful time. We always do the Q&A towards the end, which is amazing. I'll just take you off screen for now and then I'll pop you back on after I finish my little section. Okay, so what courses cover this topic? It's a great question, I think. For the upcoming courses that are delivered both by the first section is the Engineering Institute of Technology, the second section being the Engineering College of Technology, ECT. So the first section, the Online Masters of Engineering, Civil and Structural, the Graduate Diploma of Engineering, Civil and Structural, the Graduate Certificate of Civil Engineering Structural. These all begin on the 5th of January 2026. We also have the Graduate Certificate in Civil Construction Management, the Advanced Diploma of Civil and Structural Engineering, and then the Professional Certificate of Competency in Repair of Concrete. All of these beginning on the 13th of January. And then for ECT, we have the Bachelor of Honours in Industrial Automation, the Bachelor of Honours in Electrical Engineering, both beginning on the 16th of February. And then the Masters of Science in Power System Analysis and Renewable Integration, and the Master of Science in Industrial Automation and Instrumentation Control, starting on the 9th of February. So keep an eye out for those. Ensure to visit the website because you will find more information there, as always. So I'll now post the certificate of attendance link, but you can always use the QR code if you feel more comfortable with that. I just, one moment, please. Wonderful. And then I'll bring you back on. Take myself off. I do believe we've had a question in the Q&A section. So it's please, I believe it's please you only talked of fittings, but never mentioned welding or joining of pipes. And then there's the how do you do metal pipeline removal services for pipeline that are old and inactive? I'll remove myself whilst you answer these questions.
Okay. Okay. Yeah. Thank you. Yeah. So I think the first question is, how do you do metal pipeline removal services for pipeline that are old and inactive? Now, depending on the pipeline, pipeline, where is it based? So that's like if it is old and inactive, you want to decommission it. That is pipeline decommissioning. Depending on the regulatory policy in the country that you are working on, that they are working from, so they may decide to say just flush it, clean it, and bury it, bury both sides. Some will say remove it. For UK now, they can tell you to remove. So they can tell you to leave it in situ. They can do partial removal, depending on the regulatory body in the nation. So that is for the pipeline removal services, to the decommissioning. And then, please, can you only talk about the fittings but never mention welding for joining of pipe? Yes, because we're only talking about piping system, we didn't talk about the method of joining. When we are talking of joining of pipe, that is actually, we are now talking about welding. There are many different methods of welding. You can do soldering, welding of pipe, different kind of welding type. We have the facao, we have the submerged arc welding. So those fittings are just part of the component. Welding is not a component. It's a method of production, a method of journey, not a component. But flanges, gaskets, those are components. So that's why we talk about the fittings. So welding is not part of what we need to talk. That's like a processes. It's welding processes. These are processes, not components. Good. Then I saw another question on the meeting chart. As a civil engineer, very good. How can I integrate all the piping system in the design? And then the software I can use to carry out the design of a piping system and pipeline, then document I can use. Now, the first advice I will give you as a civil engineer is that I will strongly recommend you should move towards pipeline system, not piping. Because the reason is that piping is more of mechanical engineering and metallurgical and materials. That does not mean that civil cannot do it, because you are talking of mechanics, but it's more of drawing and writing. But for piping, in case you still have interest, one thing about this industry is that when you finish your first degree in any engineering, you can jump to anyone. You can use Caesar 2 for stress analysis, PDMS, AutoCAD for the drawings, 3D, Autodesk. So those are the major software used for the piping. While for pipeline, you use AutoPipe, Ocaflex, OffPipe. Why I was advising you, and then the document that you need to carry out my design. The first document you'll be looking for in any project is your basis of design. It's the Bible of every project. It tells you everything you need to do on that basis of design. Then from there, you take it there. But for pipeline, why I told you that maybe you should tend towards pipeline, because as a civil engineer, you did something on geotechnical, which is you did something on environment. So you go to be more familiar environment. We always civil engineers always become a very good people that are civil engineering, a very good pipeline engineering. So that's just the advice. So what we have is okay. This one with MDDOP and mechanical engineering diploma can one be called? Yes, you can. You just that I would strongly recommend the moment you have a diploma in mechanical engineering, try to go for your first degree. But with this one, you can become a pipeline engineer. But just that it may be a bit difficult for you because there's some advanced mechanics analysis that you will struggle. But if you have your bachelor's degree in mechanical, it will be easy for you. So that's for so you can be a pipeline engineer, but I would strongly recommend you should further your education. You said we have a field cooling water pipe embedded within a strong concrete foundation. After nearly 20 years of work, the pipeline has developed a leak, which technology can be used to examine the extent of the rupture. So we have to do what we call failure analysis on that. So now using technology, depending on the leak detection, since it's 20 years, so definitely the pipeline has degraded, but so we perform what we call an FE or engineering critical analysis. But the first thing we need to do, we do the failure analysis and then see the without damaging or affecting the surrounding concrete. Depending on the level of the damage, we determine what we are going to do in the second one. So when we examine it, do a proper failure analysis and do what we call a root cause analysis, then from there we will now decide which one to do. However, if you are looking for a repair of a pipeline that is embedded in a concrete and you want to repair because there's a leakage, that does not mean that, but unless it's a small crack, there's no way you will still find a way to touch the concrete in the real sense. Then the pipeline internal coating is significant cost for pipeline. Yes. Please, could you highlight some example of lining for abrasive material like sand, especially for water transport? Now, pipeline internal coating, we have different kind of coating. When you're talking of pipeline internal coating, we have the clad type, we have the line pipe. Now, the clad type is the mechanical bonded coating that is embedded with the pipeline, like CRA, corrosion resistant alloy, and we do that and it's very expensive. And the other one is clad pipe, line pipe, which is mechanically bonded. So that one sometimes is a bit cheaper, but we always consider using those things when there's a highly corrosive environment. Now, the water you said is carrying now is water is very corrosive, but not as corrosive as it is like the oil and gas. And because you are taking of the abrasive material like sand, yes, but I will, if I go to design this one because of the cost, I will consider putting what we call a corrosion allowance. That means you increase the wall thickness for water pipeline so that we actually take care of some of those challenges. Good. Another question. Let me go to another. So, ah, what's different? Okay, okay. Drip pipe, each 9 meter long. That's from. Okay, no. Somebody say, okay, how do I transition from being a mechanical engineer to become a pipeline engineer? Simple. You have started. Just take further. Very simple. You have started. That's one thing I always tell young engineer. It's easy to get information, but you need serious study to become more knowledgeable. They're going to send you some of the slide that we use today. That's the beginning of this whole thing. You have interest, you begin to explore. YouTube is a university now. Google is your friend. And before what is going on, you get there and begin to look for opportunity. So you have started, you already, as far as I'm concerned, you have transited to become a pipeline engineer because I've already told you that you're going to be a great pipeline engineer. That's John. Good. Then thanks a lot for the okay. I have an inquiry, please. Drip pipe are connected each other to drill oil and gas for, for a few kilometers. They carry drilling fluid like mud to assist drilling. Yes. Can we categorize this under piping or pipeline system? It's under pipeline system, not piping, because it's a drilling riser. So a riser is part of the pipeline system. So because they are used temporarily until the earth, yes, it's a drilling riser. So when you talk of a riser is a rising pipe that is tall, and then it's a drill riser based on the function. We have riser for the production, which is common, and we have riser for the drilling. So that is drilling riser. So and then put so that I think that takes the okay. Then if you want to become an SMP engineer, which course to take or do when you are a mechanical engineer? Sorry, what is SMP? I don't know. So that I don't answer wrongly. What is the SMP? Can you explain further? SMP engineer. Is it strengthening modification pipeline? So what's the difference between a pipe and a tube? Yes, sometimes a pipe and a tube, they like almost the same meaning. We use it interchangeably. But just as a tube is just like we use it for maybe intervention, but when you're talking of the type of materials, they're almost the same. Which direction course do I take to complete advanced? Which direction of course study do I take if I've completed my advanced? Now, there's one course in AIT, Bachelor's in Mechanical Engineering. In fact, this topic that we just taught now, we just completed the lecture for a semester on Monday in mechanical engineering. You know, you did only introduction now. They did the whole semester in this course. So you should understand what they've gone through. So please, if you have done advanced diploma, go to AIT website and register for the bachelor's in engineering. And you want to major in piping and design, you are there. You're already there. So don't worry. So is what is piping and pipe engineering an added advice for a fitter? No, piping is more advantageous for a fitter because you're already used to that topside arrangement. How do you do metal pipeline removal service for pipeline that are okay? I've already done that before. Please, okay, I've done that. So new post. Okay, structural mechanical piping engineer. Okay, let me say the question again. You see, that's a big English. That's a big English. Okay, how do I become? If you want to become structural mechanical piping engineer, do you do when you are mechanical engineer? So you already in the structural mechanical. This is just different languages. You want to be structural engineer, mechanical pipe engineer, or what you are looking for. You want to be a stress engineer. That's the language I see in all these things you wrote. We have stress engineer. They are piping engineer too, which they do the stress analysis. They do mechanical rotating and rotating equipment and so. So I have a bachelor's in water engineering. How can that? You're already there. As I told you before, any bachelor's in engineering in the oil and gas, you are welcome. You have done the basic one. So water resources engineering It's like a civil, you only did you just like you did civil engineering. It's just a arm of civil engineering. It's just someone that did geotechnical engineering too. So it's an easy area. You have started. So I'm currently studying mechanical in my last years before graduation. Just food or all. Is it what to be a pipeline engineer after graduation? You are welcome. In fact, I look forward to see you, Jema, to see you in the industry. So that is your field. So just create interest. Pick the slide, all those basic things. Go and Google it, learn more. You may not be able to do some of the calculation analysis now, but you have an idea. And just look for a company like Technip FMC, McDermott, and say you want to be an intern. Start from there. So I think we've already answered most of the question, Jasmine.
Absolutely. So this will conclude our webinar today. Thank you so much for your pure knowledge and skill in this area. It was a very thorough, and I saw somebody say excellent, which I can second. It was an excellent webinar. Very much appreciate your time today. This obviously concludes the webinar. I'm just going to take control. On this
Yes.
page, you can see on the right side, that's our ECT information, and then on our left side is the EIT information. So just follow them accordingly. Um, I know a lot of people are interested in courses in relation to this topic. You can always find those in the upcoming courses section, the most relevant ones as well. I'll conclude. Did you have anything else to say, Doctor?
Yeah, no, nothing else. Maybe some of those people that maybe they are trying to have interest in pipeline, you can just
Mm,
check my name on LinkedIn and just add me. Then from there we can any advice I should be able to can throw the question personally to the and then I can advise accordingly. Yeah, thank
that's
you.
very kind. Thank you so much. All right, I'll just end the recording now. Thank you everyone for your time.